Welcome to Home Tech Systems channel and thank you very much for watching this video.
This video is part 2 of my previous video. In part 1 video, I introduced you 3.5 kW 24V hybrid off-grid inverter manufactured by a China-based reputed company PowMr and 1.4 kW off-grid solar system installed in my home. It was to tell you importance of a good inverter in a solar system and my experiences with this inverter and my efforts to reduce electricity bill. Now this video is the second part of that part 1 video, but this time we will talk about how we configure 27 numbers of inverter settings through display screen and function buttons. In third part of this video we will explain doing the same thing remotely using Wi-Fi module and application in addition to accessing data.
If you did not watch its part 1 video, please click the link given in this video description or go to the end screen to watch the same. Now let's watch this video, which is part 2. Now we will start from LED indicators. There are 3 LED indicators. The first one is fault LED indicator. Here you will see either solid red light or flashing red light. Solid red light says that the fault occurred in inverter and flashing red light says that warning condition occurred in the inverter. Fault is more serious than warning condition. You have to solve it by checking with inverter manual or using the services of maintenance person. Now the second LED indicator, it says about battery charging. Solid green light says battery is fully charged and flashing green light says that battery is charging. Here it shows that flashing green light, which means inverter is charging battery. Now we are going to the third LED indicator, which says about which source of power provides output. Solid green light indicates output is powered by utility in line mode and flashing green light indicates output is powered by battery or PV in battery mode. Here we see that green light is flashing, which means load is powered by battery or PV. Now we will see function buttons. There are 4 function buttons. We use these buttons to control LCD display information and settings. The first one you can see is enter button. When we press and hold this button for 3 seconds, the inverter will enter into settings mode. Besides, when we select an item in the menu, we can press enter button to confirm that selection and save it. Next 2 buttons are up and down. We use these buttons to go to next or previous section in LCD display or settings. The last is escape button. This one is we use this to exit setting mode. Now we will go to a big section which is about LCD display settings. We will explain how we can configure settings that decide how the inverter do actions in different situations. In my old locally made inverter, which I used for 2 years, there were no settings except 3 switches. In this high frequency branded inverter, we can program 27 settings from 1 to 36, which we are going to discuss now. If the screen is off, pressing up or down button will bring the screen display on. Keep the enter button pressed for 3 seconds. Now the screen will enter into settings mode by showing program 00 escape. Now press up arrow to go to program 1. Then to enter into options of program 1, you have to again press enter. Now pressing up or down button will loop between the options in program 1. After selecting your required option, you have to again press enter to confirm selection and save. This is the way we configure our setting in each program from 1 to 36. Now we will show first the list of program number and the short description with the default values for your easiness. Now let us go through each program setting. To begin, we need to enter into setup mode. Now we press up arrow button to enter into program 1, which is for setting output source priority. We know that there are 3 sources of power we can connect to inverter: utility power, which is KSCB, solar power, battery power. We can tell inverter that which among these three has priority in providing load. There are three options in program 1 setting. First is utility. Utility power has the first priority. Solar and battery power will be used to provide power to the load only when utility power is not available. Second is solar. Solar power has first priority. If solar is not sufficient, utility will provide power to the load at the same time. If solar is not sufficient and utility is not available, then only battery provides power to the load. Third one is SBU priority. Solar has first priority. If solar is not sufficient, balance load requirement will be from battery. That means both are shared to provide load. Utility provides power to the load only when battery voltage drops to either low level warning voltage or voltage point set in program 12. When SBU priority or solar first is configured here in program 1, then only we can set low voltage point in program 12 to transfer load source to utility power source, and set high voltage point in program 13 to transfer load source back to battery power. So here we select SBU option because we prefer solar, then battery, then utility. Now we press enter to confirm selection and save. Program 2 is to set up the maximum charging current. If charging current is below or equal to this maximum, the inverter will charge the battery. It will be the total of utility and solar charging current. We can set any value which is multiple of 10 from 10 ampere to 100 ampere. 60 is the default. Additionally, for your information, I am showing a video of lead acid battery in which the battery manufacturer states in the battery sticker that maximum charging current should not exceed 10% of the rated capacity. So 20 is the maximum charging current for this 12 volt 200H battery. Since we have two batteries, it is 40 ampere. Next is program 3, AC input voltage range. We can set up input voltage range either to APL or UPS mode. Voltage for appliance or APL ranges from 90 to 280 volt AC, and voltage for UPS ranges from 170 to 280 volt AC. APL is default. In UPS mode, transfer time between input sources will be 10 milliseconds, and in APL mode it will be 20 milliseconds. Since we are using desktop computer, we will set program 3 in UPS mode since its transfer time is only 10 milliseconds. Next is program 5 to specify battery type. There are three options in program 5. AGM is default. Absorbent glassite or AGM batteries are advanced lead acid batteries and hold their charge well because liquid is sealed inside the battery and are less likely to sulfate when compared to conventional lead acid batteries, also called wet cell batteries. Liquid electrolyte flows freely inside conventional batteries. Second one is flooded batteries or wet cell batteries. These are not usually sealed and do not recombine the gases to liquids internally. Instead, internal gases produced are released directly to the environment. Flood batteries require maintenance in the form of water. Lead plates start to deteriorate when they touch the atmosphere. If you fail to maintain, they will corrode and fail, but they hold very good rates for charge. Next one, and the third one is user defined one. If it is a selected battery charge voltage and low DC cutoff voltage can be set up in program 26, 27 and 29. 26 is bulk charging voltage, 27 floating charge voltage, 29 low DC cutoff voltage. Now we have selected and save this option, that is user defined one. Program 6 to 10 settings are easily understandable. Program 6 is to work auto restart when overload occurs. There are two options inside this one, a restart disable and a restart enable. We do not change the setting because restart disable is default. We do not want to change this setting. Now program 7, auto restart when over temperature occurs. There are two options, we can disable and enable. Enable is default, so we do not change the setting. Default is okay for us. Program 9 is output frequency. There are two options, we can set 50 Hz and to 60 Hz. 50 Hz is default. We do not want to change the setting also. Default is okay because 50 Hz is what we want. Now program 10 output voltage. We can configure three output voltages, 230 volt, 220 volt, 230 volt, 240 volt. 230 volt is the default. We do not change it because default is okay as utility power source is 230 volt and instruments at home also will work in 230 volt, so we do not change. Now next program is program 11. It is related to maximum utility charging current. Program 11 is about setting maximum utility charging current. Remember that we have set maximum charging current in program 2 that includes both utility and solar current. Here we set only utility charging current. We can set any value that includes either 2 ampere or a multiple of 10 ampere up to 80 ampere. 30 ampere is the default one. If setting value in program 2 is smaller than that in program 11, the inverter will apply charging current from program 2 for utility charger. Now program 12, setting voltage point back to utility source. In program 1, when SBU priority or solar first is selected, then battery will be used to power the load and later battery voltage will drop to low voltage point at which the load will be transferred to utility source. It is that low voltage point that we set up here for the load source to shift to utility source. We can set any values of multiple of 0.5 volt from 22 volt to 25.5 volt. 23 is the default. Program 13, setting voltage point back to battery mode. Program 13 is the reverse action of program 12. That means when the battery voltage dropped to the low voltage point set in program 12, load source has been transferred to utility source. When the battery voltage is restored to the point we set here, then the load source will be switched back to battery mode depending on the SB priority or solar first option selected in program 1. We can set any value which may include full or any value of multiple of 0.5 from 24 to 29 volt. 27 is a default. Next is program 16. In program 1 we have set priority for the source of load. In program 16 we will set priority for the source of charging battery. There are 4 options available. Utility. Utility will charge battery as the first priority. Solar charger will charge battery only when utility power is not available. Second one is solar first. Solar will charge the battery as first priority. Utility will charge battery only when solar is not available. Third one is solar and utility. Solar and utility will charge the battery at the same time. This is the default one. Fourth one is only solar. Solar will charge battery no matter utility is available or not. To reduce electricity bill from government authority, we have set only solar option. Utility is never used to charge battery. Program 18 is about alarm control. When utility power comes and goes, when battery voltage drops to set value, or when other event occurs, inverter makes alarm. We can set alarm on and off in this program setting. Next is about auto return to default display screen. This is program 19. When the inverter is switched on, we see default screen. When we move to other screen by pressing down or up button, screen display return to default screen after no button is pressed for 1 minute. By setting in program 19, we can make screen stay at the latest screen. ESP return to default display screen. FEP stay at latest screen. Program 20 is backlight control. We can control display screen's backlight on or off. Set backlight on is default. Now program 22 beeps while primary source is interrupted. We can set beep alarm on or off when primary source, that is utility, is interrupted. Set alarm on is default. We can also set beep alarm off. Next is program 23 overload bypass. When overload bypass is enabled, the unit will transfer to line mode if overload occurs in battery mode. Bypass disabled is default. Program 25 record fault code. When it is enabled, it will start to record fault code for the faults occurring. Record enabled is default. Next program we can set up is 26 bulk charging voltage or constant voltage. During the battery charging process, in the initial process called bulk stage, a constant current is pushed into battery and voltage increases constantly till it reaches a set point configured into charge controller by you or manufacturer in order to maintain a constant voltage in battery terminal. It is this set point that we call bulk charging voltage or CV voltage. You can understand this process in the graph picture displayed here. If user defined is selected in program 5, bulk charging voltage can be set up from 25 to 31 volt for 3.5 kilowatt. Default is 20.2 volt. I have set bulk charge voltage to 27.9. Now program 27 floating charging voltage. In bulk charging stage, a constant current is pushed into battery, so voltage constantly increases. It continues till bulk charging voltage we set is reached, after which in certain stage, in order to maintain a constant voltage in the terminal, charger will be pushing a less current. The level at which the amount of current is reduced to keep the voltage level constant is float voltage level. Battery is fully charged at this stage. So float voltage is the voltage at which a battery is maintained after getting fully charged to maintain that capacity by compensating for self-discharging of the battery. If user defined is selected in program 5, floating charging voltage can be set up from 25 to 31.5 volt for 3.5 kilowatt. Default is 27 volt. I have set the same default voltage. Next is program 29 low DC cutoff voltage. If user defined is selected in program 5, low DC cutoff voltage can be set up from 20 volt to 24 volt for 3.5 kilowatt inverter. Default is 20 volt. At this voltage, load will be disconnected to save battery life. Now program 30 battery equalization. Lead acid batteries suffer from the process of sulfation. This happens when the sulfuric acid inside the battery cells form tiny crystals on the lead acid battery plates, thus blocking that part of the plate from activity and reducing battery capacity and performance. To avoid this, a flooded lead acid battery should be equalized on a periodic basis by the process of controlled battery overcharging to clean off those crystals. If user-defined or flooded is selected in program 5, battery equalization can be enabled or disabled. Now we will see program 31 equalization voltage. As you know, equalization is done by increasing battery voltage. A 12 volt battery has 6 numbers of 2 volt cells connected in series. A slight overcharge is applied to ensure the lowest cell voltage is at least 2.5 volt. Equalization, when done properly, generates a slight heating of the electrolyte and forces current through plate areas that may be mildly sulfated. The resulting effect removes any remaining sulfation. The following table compares advantages and limitations of various peak voltage settings for normal battery charging in order to help you decide a slight increase in voltage for equalization voltage. As in the table you can see 2.3 volt to 2.35 volt compared to 2.4 volt to 2.45 volt per cell. You can see the advantages and limitations. So it is recommended equalization voltage in 2.4 volt to 2.5 volt per cell. As you can see, for 24 volt cell we can set 29.4 volt. Battery equalization voltage range is from 25 volt to 31.5 volt for 3.5 kilowatt inverter. Default is 29.2 volt. We need to configure an equalization voltage depending on charging condition of battery, room temperature, intensity of sulfation, etc. Now program 33, battery equalized time. Equalization must be time limited. In program 33 we have to specify how long equalization to be active. Excessive voltage for long time can cause permanent damage to battery. After it started, battery will remain in equalized stage until battery equalized time is arrived. Battery equalized time setting ranges from 5 minutes to 900 minutes, that is 15 hours. Default is 1 hour or 60 minutes. Program 34, battery equalized timeout. In equalization stages, when battery equalized time is expired and battery voltage does not rise to battery equalization voltage point, the charge controller will extend battery equalized time until either battery voltage achieves battery equalization voltage or equalized timeout setting is over. If battery voltage is still lower than battery equalization voltage, then charge controller will stop equalization and transfer to float stage. So equalized timeout setting is used when battery equalization voltage is not achieved within the battery equalized time. Battery equalized time setting range is from 5 minutes to 900 minutes. Default is 120 minutes. Program 35, equalization interval. It is the interval time after which equalization function is next activated. Battery equalization interval range is from 0 to 90 days. Default is 30 days. Now we will discuss the last setting, program number 36, equalization activated immediately. If equalization function is enabled in program 30, this program 36 can be set up to enable or disable immediately battery equalization. If enabled, LCD main screen will show E9. If disabled, it will cancel equalization function now until equalization interval specified in program 35 is over. Disabled is default. So if you want to activate equalization, first we can set 5 necessary parameters that include battery equalization enabled, set equalization voltage, equalized timeout and equalization interval. Then enable program 36 equalization activate immediately. It will start equalization immediately or keep it disabled to activate equalization next time, that is after the equalization interval which we set in program 35. Dear friends, I have tried to explain 27 settings and show you how to modify and save them to meet your requirement. We have tested and explained what each setting is and showed you how the inverter responds to each event. I hope you can now configure the inverter or similar inverter very easily. If you have any doubt or suggestion, I am happy to read and reply to them. If you like this video, please give your valuable like, comment and share. Also subscribe my channel and press the bell icon to support me to have similar videos reach you. Now let me wind up this video. Thank you for your support and time.